Okay, I'm going to get started then. So, this is Alan Percy. How long ago have we met?
I think we met at a hackathon in London.
In London.
Yeah, a few years ago.
It was Alan's hackathon, wasn't it?
Yep, Alan Quayle's hackathon.
Yeah, that's the one.
Yep.
And you've moved about a little bit, haven't you?
Yes, yeah, I have.
I'm sure you'll maybe mention this in your talk.
Sure,
yeah,
I will.
Great.
Yep, a little bit of background.
And Alan really knows his stuff when it comes to VoIP in general.
I've been around for a little while.
Yeah.
Yes.
Yeah.
Yeah.
And Alan's another person that I look on Facebook, and every single weekend I'm like super jealous. He goes hiking in the mountains in snow, and then like rides down. Go rafting and things, don't you, as well?
Well, I have all kinds of passions. As my wife says, there isn't a toy that you haven't bought.
Right.
So yes, I got a serious problem with that. Yes.
It's not a problem.
I know.
It's amazing.
Chris and I are, well, he just left the room, but Chris and I were comparing notes about motorcycles last night, and it's a sickness, you know.
Right.
So, yeah.
So, Alan's great. Alan knows what he's talking about. I'm not going to bore you introing him too much because he can do it well himself. So, everyone give Alan a round of applause.
Thank you.
Thank you very much, Alan.
I just also want to tell you, Dan, I appreciate the instructions because I really messed this up in my room last night. So now I know how to do this. So thank you very much.
Yeah. I don't really know what to say to you, Alan. Like, I kind of feel bad for you.
It kind of turned out where half the letters were still on the one sticker and the other half on the other, and it just was ugly. So now I have another one ready to go. So
Thank you, Alan.
So I will fix that sticker problem. Anyway, good morning, everyone. Thanks for joining me and sticking around this morning for the session. We're going to talk about session border controllers and about back-to-back user agents with the intent of hopefully bringing everyone up to the same point of understanding the role that they play in the network and kind of the functions that they participate. A little bit of background. Dan did a wonderful job with an introduction. I shared some folks at breakfast this morning. When I first started working in telecom, it was in the late 80s, developing telephone wake-up systems for hotels, writing low-level device drivers, those kinds of things. So I was the developer the first 20 years of my career. I got into product management, and of course with that comes eventually marketing skills, et cetera, et cetera. Eventually moved over to the dark side, to the marketing side of the business. And right now, I'm the Chief Marketing Officer at Telco Bridges. So it's been a lot of fun. We've seen a lot of things. I've seen a lot of technology change. But some things never change, right? Software, the difficulties in debugging, et cetera, don't seem to have changed. But one thing I did want to notice, a couple different ways to keep tabs on me. I'd love to have you all join me on Facebook or LinkedIn or whatever your favorite platform is. But I have a podcast called Telecom Disruptors, and it's really focused on those people that are disrupting the industry or have disrupted the industry. So if you'd like to join me for a podcast tomorrow, I'm going to try to grab a spot someplace here in the building and do a little maybe 10 to 15-minute sit-down interviews and talk about what you've done in the telecommunications space. And it's kind of a fun. I've got a couple of dozen people who have already sat down over the last 6 months or so. But it's my way of trying to capture how the telecommunications industry has changed through the people that have made it change, which is sometimes gets ignored. Anyway, who is Telco Bridges? As I mentioned, I joined the company about 18 months ago. It's a manufacturer of voice over IP media gateways, signaling gateways, and more recently, session border controller software. It's a privately held company. 2002 was founded. Has been very successful in delivering very high scale, very highly reliable media gateways and signaling gateways into the service provider community. So they have a lot of expertise in the reliability, fault tolerance, 1+1, failover, kind of on-the-fly software updates, these kinds of things that have to happen in the core of the telecom network. 35 employees, most of them sitting in Montreal, actually in Boucherville, which is the South Shore for those of you from the neighborhood. It's a great group of people. It's a true joy when I get to go up there once a quarter or so And joining me is Luke Morissette. If you haven't met Luke yet, please do take a moment to say hi to Luke. I live actually outside of Buffalo, New York, and work from my home office in Orchard Park, New York, which is home of the Buffalo Bills. You've probably seen my stickers all over my laptop. And it's one of my flatulence. Yeah. So anyway, yes, it's self-punishment. Anyway, so I wanted to talk about some of the risks first from the network. So you're building voice applications. I know some of you are web developers, and some of you have been in the voice space for a little while. But I want to talk to you about the risks, and then we'll get into why this all came to be. Well, the first one is extortion. I think we all know that right now is one of the big threats, which is if you don't pay me, I'm going to destroy your network, or I'm going to crash your servers, or whatever it might be. And we have very interesting anecdotal stories of developers who built applications, put them out on the internet. Some sniffer finds it, and then somebody tries to extort, says, if you don't pay me, I know there's a bug in the software that you're running, and I can see you're using a certain version of asterisk. I know how to crash that asterisk or overload it very easily. And if you don't pay me $10,000 in Bitcoin, I'm going to crash your server at midnight. Bam, they crash it at midnight, you ignore them, and the next thing you know, you're a victim of them and this extortion. It happens at businesses, it's happened to hospitals in the States. Regional governments have suffered from it. It's pretty nasty. And of course, we need to prevent that. The second one's intrusion, which is just getting in there and stealing identities, credit card numbers, social security numbers, these kinds of things. And this has become a problem. And they usually use that data then to then either cause extortion or the worst, which is the theft of services. And this is one of the biggest problems that always has been part of the telecom industry, which is people using your network or your equipment to make calls without your permission, driving up your operational costs while they make money off of it. And this seems to be a pretty common problem. So these are the three core risks that seem to happen. And one just sort of anecdotal story that had gotten a lot of press. Is this poor gentleman, he runs an architecture firm down in Georgia, and he lit up his new telephone system, cut over to a telephone system by a major free open source software system. And he came back in the morning, on Monday morning, to a $166,000 phone bill because somebody had found a way to use theft of services to make long-distance calls to Liberia all weekend. And he got clobbered with this bill. And what it was is one of those, what they call like the equivalent of a 900 number, a premium number in Liberia. And he got clobbered with this huge phone bill. And he went public with it because he wanted other people to share his story to make sure that it didn't happen to others. We've had dozens of other people tell us similar stories that are not quite so eager to have their story told, but it's happened. It happens all the time. And matter of fact, Luke, in preparing for the hackathon that we have later today, stood up 5 of our session border controllers on our Amazon account. And before he got a chance to set the filters for the IP address, SIPP Vicious had found it and was trying to hack it. So it just took, 5 minutes or something like that for someone to find it? Yeah, it's scary. There's some bad guys out there. So let's just talk about SBCs. I got a quick agenda here. So, we'll talk about what are they. Because we're going to talk about it relative to some of the other platforms you're probably accustomed to. What do they actually do? What are some of the use cases for them? And then we'll talk about what are some of the trends in telecom, at least, for how they're being applied. And then we'll talk about where you can get free evaluation software that you can go ahead and work with. And then we'll wrap up with where to learn more. We've got a couple of events coming up. So first of all, I just want to share with you that that this is a tool. That basically, a session border controller is a tool. And how many of you? Did anyone do woodworking or kind of mechanical work or anything like that? A few of you, okay. You know that there's many different kinds of screwdrivers. There's many different kinds of chisels. There's many different kinds of hammers. All right, and this is the same thing with these kinds of tools. This is not the solution for everything, but it's really good at what it does, but there are other tools that do similar things that are better at what they do. So this is, should be one of the tools that as someone who's developing telecom or telecommunication applications, you should be aware of, you should know how it works. So hopefully that's what I'm today trying to get through, is that that you'll have this as a tool as part of your quiver. And to kind of remind you too, by the end of today's session here, Luke's going to pass out. We had up these really nifty little pens made up that not only are a pen, but there's a screwdriver underneath the eraser. There's 2 screwdrivers. There's a level, and there's measuring markings on it. So it's kind of a nifty little tool for your. So stick around, and he'll hand those out when we get towards the end of the session today. So, but this is, SBC is a tool for the workshop. So I think everyone is probably pretty familiar with SIPP, but I know there are a couple of web people I talked to. Just a couple reminders. SIPP was defined by RFC 3261, and there's been I don't know how many iterations of RFCs beyond that. But one of the key things is the specification is pretty loose. There's a lot of mays in the specification, the word may, loose language in the specification. And every one of the vendors who've built SIPP-based applications has taken their liberties with that specification. And one of the challenges for an application developer is each service provider, each IPPBX, each other IVR system that you talk to is going to take its liberties with it. For example, Microsoft likes to do SIPP over TCP, and they like to have a fully qualified plus telephone number for every phone number. Other people just throw the last 4 digits as a PBX in the invite. They don't need the full phone number. They use SIPP over UDP. So there's lots of little things, and this has resulted in quite a few interoperability issues. And this is one of the key challenges with developing SIPP is always the interoperability challenges. Separating the call control from the media was a great idea. The problem, as you will see, sometimes becomes a security issue, is if you may be able to lock down the session control, but if you don't lock down the media, then you leave kind of the back door open. It's also very chatty. There's a lot going on, especially with IP phones that have multiple appearances and multiple buttons on the phone. Each one of those devices has to do a register. There's all these notifies and subscribes that go back and forth. There's a lot going on. And then, the asynchronous nature of it, and of course, the fact that it does keep the state, which is, for a lot of web kind of developers and thinking, usually kind of messes the works up. You have to keep track of it. Well, and I think all of you know what the OSI model is, but one of the key things to understand is that there's an approach that, different devices or different elements of the network work at different layers within the OSI model. Certainly network switches, routers, and firewalls work from the transport layer down. Many of the SIPP servers target this layer in here, the transport and session layer. The session border controller tries to encompass everything from the application layer all the way down to the network layer to do a comprehensive security solution. Sometimes you have to have a much broader view of the network to be able to deliver that. So not only worrying about network transport protocols, but also worrying about what voice codec we're using, maybe having to convert media types in the presentation layer, these kinds of things. And session border controllers worry about all this stuff. Much more comprehensive. So I know the guys who deliver SIPP servers in the market, and we'll talk about in a second who they are. I think you know who they are. I just wanted to talk for a second about the architecture the SIPP server typically uses, and this is a super simplified picture, but it helps you understand when we get to session border controllers. But what I've got here is, the dotted line is the domain of the SIPP server. SIPP sessions, if, for example, when they come through, maybe an outbound coming into applications for an inbound call, they really boil down to a couple things. One of them is some kind of header manipulation, message manipulation. That's usually a script-based language. And then some kind of routing engine to deliver the message. But this is somewhat how they gain their efficiency, is that there's very little, they basically do the header manipulation, then they deliver the message. But the message, as it passes through, it's the same message, maybe with some manipulation that happens to it. But the key thing is the media never really goes through it. And it's only some add-ons or bolt-ons or other third-party pieces that would ever touch the media. So the SIPP sessions go through the SIPP server, but again, the media goes around it. And the side effect is that your public WAN, you might have an IP address for the SIPP server, but you need to have the applications have to be exposed because of the media. And of course, there's a couple of players that deliver these. I think you guys have probably all worked with them. They include proxies. So they can do the header manipulation, routing, load balancing. A lot of them are script-based configuration, which has, there's benefits and challenges with that. But they don't have a back-to-back user agent. And as a side effect, they expose some of the network topology, and they also expose what software is behind it as a side effect of it, which then gives the bad guys an advantage because they know their target now. And as we say, one of the great things about open source is you get source code. One of the bad things about open source is so do the bad guys. They have the source code too. So every time there's a published bug, they know exactly how to leverage it to cause problems. And last but not least is there's no media handling in these, without these bolt-ons that we've talked about. So what is a session border controller? In its rudimentary definition, it's designed to go between two networks, and here, this particular example, it's a wide area network, a local area network. The SBC sits on the border between them, thus the name, converting from one flavor of SIPP to the other, anywhere the two networks interface. And most often, when we get to the use cases, you'll see this might be, the internet here, and it might be a LAN, either in an enterprise or in a service provider on that side. It's often delivered as a software-based network function, and as I mentioned, between WANs and LANs. So the architecture, it's a little bit more complicated than the SIPP server. And a couple of elements here, I'm going to step through them, but I just want to kind of point out a couple of dotted lines here. So the dotted line defines the scope of the session border controller. It kind of hangs out of the LAN, and the LAN is the solid line, right? So that's inside the network, and this is maybe outside on the WAN. And there's a couple of elements here. One of them is the firewall is built into the case for our session border controller is built in as a dedicated firewall. That's the first stop. The second stop then is the back-to-back user agent, and we'll talk about its role and function in a second with its server-side and client-side software. The next element is the media engine, the idea of processing the media as it crosses the boundary from the WAN to the LAN. And the last but not least is a routing engine to deliver it. And the primary role of the back-to-back user agent is that as sessions come in off the wide area network, is that it completely terminates the session to its basic most simple function. So, a call wants to go from party A to party B. Here's the attributes of the call. This is what codecs I like to use, et cetera, et cetera. That all negotiation happens. It strips it down to its most basic fundamental terms, and then can reestablish a new SIPP session on the other side using maybe completely different parameters. So it might be SIPP over UDP on one side and SIPP over TCP on the other side. It might be encrypted on one side and decrypted on the other side. The benefit of that is that now this outside world can't tell what's on the other side. It's completely invisible to them. And that's one of the biggest benefits. Those applications over on the right, might be Asterisk or FreeSwitch or whatever it might be, they never expose their IP addresses or even their SIP messages to the outside world. It's completely hidden. And then similarly, the media engine can do processing, right? It can change codecs, it can do the transcoding that's necessary, or it might just simply repackage the RTP in such a way so that the outside IP addresses are never brought inside the LAN, and that provides complete isolation. So you kind of think of it as a steel door that protects what's on the one side from what's on the other side. Okay, so architecturally, big difference, right? The back-to-back user agent is an important part of what's happening. Technically, and I'll say, I drew this diagram for very simplification. This user agent client is actually on the other side of the routing engine, but for most people, it's easier to understand the back-to-back user agent. So each route can have its own client and each different configuration. So one of those could be an Asterisk server, another one could be a completely different application that needs a different flavor of SIP. Could be, for example, a Microsoft Teams application, and it can then use application needs. Okay. So the result of that is that, there always is a comparison, right? What do these things do? What's the firewall do? What's a SIP server do? What's an SBC do? And because of the the difference in complexity, a firewall can do some of these basic things, but really doesn't know the protocols. A SIPP server knows the protocols, but a session border controller adds, media topology hiding, right? So your media, the sources and destination of the media are never exposed. We can now do stir shaken on that. The quality of service, we can also measure the QoS of the media as it passes through. And that's important for analytics. Transcoding and transcription, right? So we can convert from one format of media to another through that media engine, and protect against the media denial of service attacks, right? So if they were able to open up a media session, if you jam too much media, and you can cause all kinds of problems too. So we can prevent those. All right, so let's talk about some use cases, and these are fairly typical use cases. The first is peering. This is, in the service provider world, this is one of the most common applications for SBCs. A retail or service provider would have an SBC, and most likely the wholesale service provider would have an SBC, maybe different brands or different types or flavors. But the idea is when they peer back and forth between each other and send traffic back and forth, they use their SBCs as the point of entry and exit, ingress and egress of their network. And what this does, it protects their network from the other guys, and it also lets them normalize formats. As the service providers all have different infrastructure, different flavors, they can do the conversion. But there's another side effect too, which is it also lets them do billing. They can measure the traffic that they're sending to another service provider and keep track of it with CDR, and the SBC plays that role in keeping track of the traffic to and from each other service provider. And it's generally done on the core. It might be in a cloud infrastructure, or it might be in their data center, either one of those cases. But routing is a big piece of this too, because there probably is going to be multiple service providers for the wholesale operator, or multiple wholesale operators to the retail service provider. The routing that this platform can do is very important for being able to transfer data or transfer calls to and from the appropriate service provider. Another use case is the access for SMB kind of enterprise applications. And that's where there's some kind of hosted IP phone, maybe a contact center, could be IP PBX functionality that's being delivered to an SMB or enterprise. They're probably going to have maybe an internet access device / router firewall. And the service provider wants to offer this service. And they're going to use an SBC for a couple of reasons. One of them is to be able to route traffic over to that particular SMB. But the biggest thing is to be able to traverse the NAT that would be inside that router, and to be able to keep those pinholes open. The SBC, that's one of its most important jobs in this application. And be able to manage the registrations of these devices. Each of these phones, as they wake up, will send a registration off to the soft switch, and then all these subscribes and notifies for all the buttons that are on the device need to be able to get through the SBC and into the soft switch, and vice versa. And then the phone will probably sit idle for hours and hours and hours, and to be able to allow messaging to come from the soft switch to the phone, you have to keep that NAT open. And so the SBC plays an important role in that. The next is, this is kind of hosted PBX, similar sort of implementation, but we've added the billing piece of the puzzle here because they want, this particular service provider wants to keep track of what kind of traffic goes to and from each of the service providers. So he's added a billing piece, and we actually have an end customer case study with Vital PBX who's based on Asterisk, who uses our free SBC software to be able to do this interface between the two, to be able to protect their Asterisk server, but also maintain the NAT connection to the devices. So that's kind of a neat little story, and they have a nice little platform for SMB marketplace. Another area that gets used is to manage some redundancy. It's not uncommon for once a system scales up, they want to be able to have some redundancy in the soft switch. And also redundancy in the wholesale providers. It might be multiple wholesale providers. And the SBCs are really good at providing that crosshash point where if one of the wholesale providers were to go down, or an SBC were to go down, or a soft switch would go down, that you can kind of reroute everything back and forth to whatever facilities are left up, and measure performance as it goes along. And this is fairly common. We've got a handful of customers that have right away started to leverage this kind of redundant environment to be able to route traffic from point A to point B across to the wholesale providers and give them that level of redundancy that they needed. Another one is this software as a service access kind of application. So these might be work at home, maybe contact center users, and they want to be able to have encrypted links from their IP phone or from a soft phone into an application, but the application doesn't want it encrypted. It wants it clear, like SIPP over UDP. So the SBC's job is to terminate the SIPP over TLS sessions and convert it back to the clear with SIPP over UDP to the application. Providing denial service, DDoS protection to the application, the encryption, and also do some traffic management, because there may be more than one server for that application, and spreading the load out amongst multiple application servers is a real good role for the SBC. Then a more recent one that's popped up is Microsoft, a handful of other UC platforms are now in the cloud, and they offer themselves as a hosted application in the network. But people have their own SIP trunks they've been using. Let's say they're under a 5-year contract with AT&T. They want to bring their own SIP trunk to those platforms. And unfortunately, their SIP trunks are not compatible with that particular application. So they either have the choice of going to a different SIP trunk provider and breaking the contract with AT&T, or somehow fix the SIP messages. And so they use an SBC, maybe one of the cloud platforms, AWS or Azure, and we do whatever SIP header fix-up needs to happen, and then deliver it to the application in a format that it likes, and then it can then deliver the UC application. And this is kind of a pretty common. In some cases, this is very simple little fix-up that needs to happen, little things like adding +1s to the front of the numbers. In other cases, it's pretty heavy. They have to convert from SIP over TCP to UDP or whatever, various conversions. Another one that popped up more recently is kind of interesting, and we'll talk about when we get to the trends, how this happens, is moving the functions of a telecommunications network from the core of the network to the edge of the network. And some of our service providers have started to look at using what's now called universal CPE, which are compute platforms that have the network termination technology built in. So it's an optical circuit termination, and then has using the network function virtualization technology from Etsy, hosts for various virtual network functions. I know that's a mouthful, but it'll leave it to telecom guys. So these VNFs, they host them out at the customer prem. So what they're doing is they're putting a black box at the customer prem that can support any number of virtual network functions that they own and control that box, and they deliver it to the customer site. And now they can put SD-WAN software, they could put firewall software, they could put router software, or even session border controller software out of the customer prem. The benefit for them is they can nip any intrusion attacks that might happen at the edge of the network instead of in the core of the network. So they can stop an attack out where it starts, which is at the edge of the network. So you can imagine a business gets compromised, a virus gets into their LAN, and the first thing it finds out is that there's a WAN connection, and it decides to start attacking or spreading itself into the WAN. And they can nip it right there by managing that. And in other cases, we've got a customer down in Mexico who uses this architecture to manage the traffic that comes from their enterprise customers. They have dialers, and the dialers exceed the agreed to call rate, and they're able to manage that traffic by using an SBC at the edge of their network using this VNF architecture. And it's an emerging trend. We've only had a handful of customers use it this way, but it looks like it's got real promise as a way of managing the security at the edge of the network, and then the application would actually be in the core of the network. Another one that's come up more recently is the CPaaS providers. Some of them specifically, Twilio's one of the most common ones. They would love to sell you a SIPP trunk and their services and sell you the whole shoot and match. And what happens is, again, I'm a large enterprise. I've, signed a 5-year contract with AT&T. I want to use my SIP trunks. I want to use my DIDs. I want to use my numbers. How do I connect those into Twilio? Well, sure enough, you have to use an SBC. And by putting the SBC in the cloud, we send your AT&T SIP trunks to the SBC. It can do the fix-up, and it delivers it into Twilio. And then you can use your SIP trunks for your business applications for Twilio. And this solves that interoperability issue and lets a business use their own SIP trunks. And so we've ended up with a handful of customers who do this too. And it's really helpful for them. They can manage the traffic, do the fix-up, they can measure what kind of traffic goes through it, and then they can, and one of the key things is, because they want to put this in the cloud, they actually want the media to go around it, and they use this feature called media bypass to deliver to the far end. All right, so a couple of trends we're starting to see, and we've been seeing in the marketplace, and one of them is certainly session border controllers used to be this big piece of hardware, and I think this is when people hear the name session border controller, they think of the old Acme boxes that were $100,000, very expensive. Oracle bought Acme, and it's made some modifications, and everyone has moved from these fixed hardware platforms to some kind of software platform. In our case, the first stop was virtualization, VMware, KVM, these kinds of platforms. But what we're seeing now is them move to these VNFs, the virtual network functions that they can put out at the remote edge of the network or put in the cloud inside their own infrastructure as a virtual network function. So that's one. It's the migration to VNFs instead of obviously hardware, but a quick move to the VNF space. The other one is really basically is a change in the business model. And maybe a little bit of background. A few years ago, I sat in a meeting with a up-and-coming startup service provider. He wanted to offer, I forgot exactly, I think it was conferencing application. And he said, I'm going to offer my service for free for the first year. I need to build the infrastructure, and I'm not going to have any revenue until I get to a certain point in my subscriber base and, of course, in my application. So I need a way of protecting my network, but I can't afford an Acme packet. So how do I get started? And of course, it's a real problem because he certainly couldn't afford the big upfront cost of the traditional method of selling a piece of software or a physical SBC with an upfront license and then some maintenance fees. What he wanted to be able to do is kind of a pay-as-you-grow or a usage-based plan. So the shifting in pricing and how it's sold has been probably one of the biggest changes in the marketplace. And one of the neat things about delivering just virtualized software to the market is we can adapt to this business model. Not all the vendors in the space have been able to do that, but by delivering something to the marketplace that's free to start, that takes you to a certain scale, gives you a chance to start your business, and then as you grow, then you move to the paid version of the product with better support and more features and functions, and that lets you grow your business. So you kind of start very low cost, and then you move as you grow your business. So the pay-as-you-grow model is a key change in the infrastructure of the industry. We talked about this a couple times before about moving the function to the edge with these VNFs, all right? Leaving the application maybe in the core, but moving the SBC to the edge of the network on the VNF. We're also been seeing for a while the move from the SBC being only in the service provider, but also enterprises saying, hey, I want that same level of protection to my network. I don't necessarily trust all my service providers. And if an intrusion occurs, it's what we call a resume generating event, right? If you're an IT responsible for your enterprise network and an intrusion or attack or a DDoS attack occurs to your enterprise, it potentially could cause an unplanned job change. And so they want to have an enterprise class session border controller, which is a different scale, right? Instead of tens of thousands of sessions, they want to be able to deliver something that is maybe just a few hundred sessions. So a lot of those trends have culminated into a couple of platforms that Telco Bridges has been doing this last year. About 18 months ago, we launched Free SBC, and Free SBC was all the core functions of a session border control. I'll show you in a few moments. And then we more recently announced that we'll be delivering Pro SBC to the marketplace with many enhancements. And the Free SBC platform is actually the same binary, but it's just the difference in the permissions and licenses between the two. But Free SBC is really targeted towards the small, the tier 2 and tier 3 service providers, plus some SMB and enterprise. It's good at access and peering. It's great for the open source community, which is why we're here, and some folks have started to work with it. I think our number one response to what software you're going to use this SBC with when people download it is asterisk. By probably 50% of people respond to that. It's great for education, right? It's free, so people can use it in classroom environments. Easy to download and use. You just basically fill a form out on the web, click download, and the software comes to you right away. But it works with a community support model, right? We have a wiki and a forum, and people help each other on that, and they work together with that with a sort of best case support model from a support team. And it's free, and all you have to do is annually renew it every year. That's all. You just have to tell us you're still using it and go on and re-register every year, but it's free. We have, though, the summer, we're going to be releasing the Pro version of it, the Pro SBC. Right now it's under beta, and it's targeted towards a bigger audience, right, the tier 1 and service providers and enterprise. Similar sort of use cases, but with also focused on the software as a service who need that encryption, decryption functionality. More targeted towards commercial applications with the encryption support, but it comes to live support. And this is, you would have an agent that you're probably going to be working with. We have two of them, Luke and his team have got a couple of people in Montreal, someone in Turkey, person in Hong Kong. So we have around-the-clock support. And it's pretty cheap. It's only $1 a session. So if you did a 5,000 session deployment, you'd get 5,000 simultaneous calls through the SBC. It'd be $5,000 a year. So it's very affordable, and it kind of meets that pay-as-you-grow model as we go. And just a little more detailed comparison between them. Free SBC has the full B2BUA with topology hiding, comes with the DDoS protection, and with whitelisting and blacklisting. Does all the routing functionality we talked about earlier, does all the SIPP header manipulation. So it does all the basics, but then where you get into some of the more advanced things, some of the media bypass, transcoding, plain recording, analytics, API connectors, the encryption, and some of these other functions here, that's only on the Pro SBC product. And as I mentioned, Free SBC is free, Pro SBC is $1 a session, so it's pretty straightforward. So a couple of different options for how to deploy this. It can be deployed on a bare metal servers, an Intel with DBDK. So that is an option. We have a lot of people who use just the bare metal installation, but it also goes, we have a VMware KVM OpenStack version of it, and that's pretty popular. And then also more recently, AWS, and we just added Azure support to Pro SBC for people who want to put it in the cloud. And then lastly is the VNF on the universal CPE, and we've certified with Ciena and with Telco Systems, who are two makers of those universal CPE devices in the marketplace. And usually the number one question we get is, what are the performance metrics? Well, on a high-end bare metal server, we can get up to 60,000 sessions with media through one box. And then if you decide you want to transcode, with our transcoding DSP farm, you can get up to 30,000 sessions per box. So it's a very high performance, very lightweight software. Some of the other software packages that are on the market were rehashes from dedicated hardware and don't have anywhere near the performance of this. So if you compare this apples to apples with other vendors, you'll find out this is really, really high performance. Compatibility, this is just a quick logo NASCAR kind of, this is the kinds of software people are using it with every day, from IPPBXs to, we got some stir-shaken platforms, so Transnexus, IPPBXs, billing systems, and soft switches. And one thing I wanted to point out too, so we have a webinar coming up On the 18th of July, with Telestacks and Network Intelligence, we're going to talk about CPaaS platforms and building the building blocks necessary to deploy CPaaS. So I'd love to have you join us for that. You can, if you want, you can go to telcobridges.com or freesbc.com and you can register for that. And kind of in a summary, now you know enough to be dangerous, and there's all kinds of different resources that we'd love to share with you on this. And so I'm going to kind of open it up for some Q&A, and Luke is going to got the microphone, and he's got some goodies that he's going to be handing out here as we go. So any questions? Yeah.
Are you certified by Microsoft?
We are not yet certified with Microsoft, although we have tested with Skype out, which is the Skype SIP trunking. We've got that tested and working, but Microsoft, we've not gotten through the Microsoft Teams testing yet, but it's on our list. It's on the roadmap.
We have a lot of customers that when they have problems and they speak to Microsoft, well, they're not certified, so no, we don't support them.
Yes.
So we need to find somebody that's easily to deploy that Microsoft will actually say, oh, we'll work on it, because otherwise Microsoft says, oh, not our problem.
Yep.
We can never do no wrong.
Yeah, I totally understand. I've gotten a stiff arm from them. I know very well. Yep, thank you. Good question.
Do you guys support fully HA? Like, would a secondary device take over all the active calls if the primary device fails or something?
Yeah, we have full 1+1 HA, where if a primary node were to fail, the secondary would pick up right where it left off. They have a shared database between the two. The network bandwidth requirements between the two are pretty high. So the only area that gets a little sticky is when someone wants to put the second unit in another geographic spot is the network connection between the two of them. But yes, yeah, with full 1+1 HA. Yep. Yeah, good question. Any other questions? Yes.
Yeah, I was trying to work out the commercial model behind this and the driver for doing it. I think I've come to the conclusion that one of the objectives of this is to sell your media, your DSP hardware, which is what Telco Bridge is really known for traditionally. Is that right?
Well, you know what's interesting about that question is yesterday when Dave was doing the open source discussion yesterday morning, what's the drivers for open source? Now, this is not open source. This is commercial software.
Yeah, I was just thinking how brave you are standing up. And you had one slide which actually, really took me back, having a go at dear old Camellia. And I feel compelled to get on my Camellia hat and put it on. And OpenSIPs. And I'm going, you know what? You're very brave putting that slide up in here.
As I said, they're different tools. They have different functions, and I wanted to make sure everybody understood the differences between them. They're not necessarily direct competitors. But your question is really about what's the business model. And absolutely, one of the side effects of free SBC has been awareness of the media gateways, the signaling gateways, the SS7 gateways. It's definitely helped raise the company's awareness in the marketplace and help them with the media gateway market and build the sales on those. But in addition to that, too, as we convert more people over to the paid support plans that come with Pro SBC and with Free SBC, that's generated some revenue, too. But it's from a business strategy standpoint, it is a loss leader. No two ways about it. When you're giving away free software, you don't make any money on it. So, yes. Yep.
Yeah, and just to tag on to what he said, you did put up Camellia and OpenSIPs, and I have to say that they can do some of the stuff that they had on X that actually the slide indicated that they can do, they can actually do.
So there, one of the things I wanted to make sure is there are some add-ons that go with some of those things, and you can certainly bolt on some other functions on the Camellia and on the OpenSIP. There's no two ways about it. The point I was trying to make is, for example, the back-to-back user agent, some of the functions. This is native, built right into it. This is not a bolt-on to the application, and it was designed from the ground up. That's the core of the solution. It's a different approach, a different tool, and I'm just trying to provide some contrast so that people understood the differences between them. So that's the point I was trying to get to. Hopefully, understand.
Yeah, but I just want to add, like when you say bolt-on, it sounds a bit harsh, but I think even there are people from the open SIPs community. I think they even have a module which has the B2BUA.
Right. So it's
So
you know, it's an add-on module. Right.
Yeah.
Right. Whereas this is just native. This is core of the product. Yep. So, okay. Yeah. Any other questions? So one thing before you leave, I'm going to put Luke at the back of the room. If you decide, we've got these really nifty mechanical pencils, like I said, that you might want to grab a pencil before you leave. And we have our session later today. We participate in that hackathon that this afternoon is with Simwood and also with Cloudonics. That we're going to have hosted versions of our free SBC on Amazon that are part of that hackathon. You'll get a chance to actually see it firsthand. You'll get a chance to log into it and work with it as part of that process. And we've created a little special challenge, which is kind of along the lines of the theme of our stay here, which is it's kind of spy-oriented with like an escape room. So I hope it'll be a lot of fun. I think it'll be very interesting. And we got all kinds of goodies we'll be giving away later this afternoon, too, as part of that. So don't miss that. All right? And with that, I want to thank you all for your time and your questions, and we will be moving on to our next presenter here in just a couple of minutes. So thanks again.